Hello Chem 1B, this is Chapter 16, Lecture Video 4, and in this video we're going to talk about how to calculate the pH of strong acid solutions just based off the strong acid concentration, or vice versa, from pH get the concentration of strong acid. So in concentrated solutions of strong acid, the only source of H3O+ comes from the strong acid itself. Therefore, the pH of our solution is really just directly related to the initial molarity of the acid itself, because all the H3O+ in solution really came from our strong acid. And since it's 100% dissociation or ionization, whatever the concentration of our strong acid is, if we take the negative log of it, that's the pH, because the strong acid concentration will be equal to the H3O+ concentration. So we can determine the concentration of a strong acid solution just by measuring its pH in a lot of cases, as long as we know that there's only one strong acid present. So for instance, if I had an unknown concentration of HNO3 present in water, and that's it, and I measured the pH and I found that it was 2.34, I could calculate the concentration of HNO3 in the solution just by taking 10 to the negative 2.34. And if I do that, I'll get that my concentration of HNO3 in solution is 0.0045 molar. This is only true of strong acids because they are not in equilibrium. However, if we had weak acids, we would have to do ice tables and they're in equilibrium. So we're going to get into that in a later lecture video. For strong bases, there are relatively few common strong bases. For the most part, they're ionic hydroxides that are soluble. All right, so we have an ionic compound that's soluble that contains OH-. Now, primarily, that's an alkali metal attached to OH-, or it's barium attached to OH-. These are the three strong bases that I will constantly use in all my problems on quizzes and tests in this class. In sapling learning, you might also see LiOH. It's also a strong base. But these are the main four, I guess, strong bases out there. Strong bases, just like strong acids, are strong electrolytes, meaning they dissociate completely in solution. For this reason, we can take the pOH and get the initial molarity of the solution of the base. Or we could go the other way, take the initial molarity to get the pOH of our original solution, because the concentration of the strong base is pretty much equal to the concentration of OH-. There is one exception of our strong bases to that, and that's barium hydroxide. And it's because there are two OH- dissociated for every one barium hydroxide. So you need to actually multiply its concentration by 2 to get the OH- concentration in solution. Again, in order for a hydroxide to be a strong base, it must be soluble. Only soluble hydroxide salts are strong bases. So let's look at solving for the pH or the pOH of a strong base given its initial molarity, right? So you got to be careful about stoichiometry. One thing you should also know is that many bases don't contain OH-. A lot of cases, weak bases tend to not contain OH-. For instance, O2- is actually technically a base, and it forms OH-, but it doesn't contain OH- in the formula. H- is also a base. It doesn't have OH- in its formula either. NH2-, again, a base, doesn't contain OH-. So there are a number of different weak bases and strong bases out there that don't contain OH- ions. So let's do a problem, right? What is the pH of a 0.035 molar solution of perchloric acid? So generally the first question, whenever we have a question about pH, the first thing we have to ask ourselves is, what is the substance? In the case of perchloric acid, HClO4 is a strong acid. Now, we've only covered how to do pHs of strong acids so far, but all the questions in this chapter tend to look the same. And really the difference is, are we talking about a strong acid? Are we talking about a strong base? Are we talking about a weak acid? Are we talking about a weak base? Depending on what the substance is, the problem solution is going to be very different. So knowing how to determine strong acid, strong base, weak acid, weak base is very important to this chapter. But because this is a strong acid, we can say, hey, the concentration of HClO4 is really equal to the concentration of H3O+. In other words, my H3O+ concentration is equal to 0.035 molar. And my pH is going to be equal to negative log of that H3O+ concentration, and I can get that pH. In this case, the pH is going to be 1.46. All right, so we could do the opposite direction, right? What is the pH of a solution containing? So again, not an iClicker problem, just a regular problem. So same problem really, we have HClO4. Now we have a different concentration. What's its pH? Well, same idea, negative log of 0.00356. And that'll get us our pH. Again, perchloric is a strong acid, so we just take its negative log. And this gives me 2.45. All right, so hopefully that helps. If you have any questions, please let me know in my discussion sessions or via email.